In today's video, I'm showing off an OpenGL demo with a bunch of cool post-processing effects. So as you can see here, in a world here, we have a bunch of cubes and a few light sources. And up in the top left-hand corner, we have a few settings. And right now we're on night vision, night, and frame buffer settings. So we can fly around and see everything's green and pretty lit up. And I'll show you what these settings do. So if we go to none, and let's set it to daytime. So day controls what color the background of the scene is and how much ambient directional light there is. So as you can see in day, it's pretty bright. Night's a lot harder to see. And then up at the top, we can select an option. So the first option is an outline, which, as you can see, all of the cubes and all these containers get this bright blue outline around them. And then we can go windows. So windows puts 10 of these transparent glass windows in the scene, and they're all tinted red a little. So you can see this is what its normal color is. This is a little red, and through both of them it's even redder. Then we have frame buffers, which allow you to pick a frame buffer option. So this is an effect that applies to the whole screen. So the first one we can do is inverse, where we inverse all the colors. We can do grayscale, which mutes all the colors and makes it black and white. We can sharpen, which gives that very sharp, kind of grainy look. We can blur everything out. And we have edge detect, which is very similar to sharpen, however it makes the scene a lot darker, and if we set it to night, it'll be even darker. And it's meant to really highlight the edge of all the objects. And then we have night vision in day and night vision at night. The last option here was all, so we can put all the options on. So now we have an outline, we have windows we can look through, and we get a frame buffer effect. And we could change the frame buffer effect. We could go day, grayscale, edge detect. You see they all work together. All right, so let's explain how this works. So that GUI I had open is from I'mGUI, and the main code for it's right here. There's other codes you need to run to set it up, but this is the main code. So we begin I'mGUI, then we have three char pointers, and with an array of them, we have option names, effect names, and day names. And then down here we use the combo feature. So we'll say select an option, GUI view current, and we'll explain that in a second. We have all the option names and then the number of options we want. And when you click it, we change the GUI view to what we just currently set it to. And the same is true for frame buffer effects. We set the frame buffer effect to the GUI effect current. And then down here we have I'mGUI combo for select time, and then we can do is day, and there's two options. So at the top of our code, we have two enum classes, a view mode and a frame buffer effects, and these are all the possible options. And then we have a GUI view and a GUI view current, and that allows us to pick which view mode we want. We have a GUI effect and a GUI effect current, which allows us to pick what effect we want. And then an integer is day for whether it's day or night. All right, so now that you know how we pick the options, I'm going to go through each of the view options and explain how it works. So the first one is the outline that we saw, and that uses up here, and this is a stencil test. And what we do in our main loop is when we draw in the cubes, when we draw in the light cubes, when we draw in the lights, we set the stencil mask to 0. And what this does is it basically says that the lights aren't part of the stencil drawing at all, and it won't affect the stencil mask. And then for the cubes, we set for a stencil function GL always 1 and 0.ff. So this means it will affect the stencil mask. It will set it to 1 and it'll always do it. And then we draw the cubes in. And then if we sev outline or all enabled, we'll set the stencil function to not equal 1, and then we can write, but this won't mess with the stencil mask at all. So we can only draw if the stencil mask is not equal to 1, and we won't change the stencil mask at all. And then we draw the cubes in, but we use a single color shader, and we scale it up slightly, so 1.1f, so 110%. So this means that we get a 10% area where it's not 1 because of the cubes, but it is within the area of the larger cube, and that gives you an outline. Then the next one was the windows, and for the windows, we create a window vertex array object and vertex buffer object, and we have a window vertices, and then at the top here, we have to enable GL blend and the blend function where we'll blend alpha and 1 minus the alpha. So that alpha is the transparency of any texture. So we create it, and then we go down here, and if we have window or all, we create a sorted map of all of the windows, which is an array, and we sort them by distance to the camera, and then we draw them in reverse order. And if you don't care about the drawing order, then you get some will draw before others, and if they draw before others, the computer will optimize it away, and you won't be able to see it, and you'll look through the window, and there'll be nothing there. It's a weird effect. This is how you solve it. And then the last one was the frame buffer. So the frame buffers, we create a frame buffer object, and we bind a frame buffer object, and then we create 2 textures, an FBO color and an RBO. RBO covers a GL, it's a depth and stencil, and this one covers color. And then what we do is we have up here a screen vertices right here, and then we have screen vertex array, screen vertex buffer object. And then at the end of our code, if we do have frame buffer, at the top, first thing we do is if we're using frame buffer, we bind this frame buffer, and then we draw the entire scene onto that frame buffer, and then we clear the screen, disable depth testing, and then draw it again using this new array, and we only draw 6, and the screen array basically just covers the entire screen. So in essence, what it does is instead of it drawing separately to the screen, it draws everything separately, and then it draws it onto one texture. And what that lets us do is if we go into this quad fragment shader, it allows us to apply effects to the entire screen. So if we set the effect to 1, we take a vec3 of 1 and then subtract texture, so this gives us the invert. If we have an effect of 2, which is the grayscale, we average the 3 colors together, and then we just set each of them equal to the average. If the effect is equal to 3, we do this one, which is a sharpen, where we take a kernel, so this is a 3x3 grid, and we basically, each pixel, we multiply the surrounding pixels by these values, and then the center pixel is what's multiplied by that. So this one, it mutes the other colors around it, and then it really enhances the central picture, or the central pixel, and that gives it kind of that sharp look. And then effect 4 is a blur, so you can see all of them are like 1 divided by 16, 2 divided by 16, and 4 divided by 16. So this really spreads out the effect of the pixel. Effect 5 is the edge detect. So it's 4 negatives, 1s, and a 4. And this means that the total result is 0. So that makes the entire scene dark. However, any pixel that is like on the edge, so where this -1 won't do as much, you can really notice. And then effect 6 is the night vision. So this is a sharpen, but we have, it's 10 instead of 9, so it's brighter. And then down here at the bottom, we do not take a color red or color blue. We simply set the color green equal to the color we get times 0.75, and then we add half of, or red plus blue, and add a quarter of that to the color. So that makes everything green. However, it means that a red light will still appear faintly on the screen, just as green. And that is it for this video. I hope you enjoyed. And if you're interested in how we did all the lights and all the flashlight, the directional light, and the point lights, you should click on the video to your left. And if you're interested in another OpenGL demo I did where I loaded models into the scene, you should click on the video to your right. And until next time, see ya.